Hello guys, this is question number 5, and we've done this in lecture, and so Euler's method, however you say this guy's name. But the method is, if you guys remember it from the lecture, and I do wish you guys remember the equations, they are given, but it would be great if you guys remember it. It would save you some time on the midterm. So what it says here, you have a step size of 0.1. So step size is your h actually. So your h is your step size. All right. Remember we said the bigger your step size becomes, the less accurate you become, and the smaller your h becomes, the more accurate your approximation is. Don't forget, this is an approximation. And so that's why he says estimate. So we're estimating at y equals 0.5 or at x equals 0.5. And we have this equation, which our equation, I'll write it here. It's y prime equals y plus xy. All right. And it's giving us our first values, which is at x equals 0 and my y equals 1. Okay. And so I drew this little table here. Here we have your step. And here you have your x current or your xn. And your equation to get your x pass or your current x is here. Actually, we'll go into it in a bit. So this is your y current or yn, right? And so here we have step 0. At step 0, we have these two values is x0 and y1, right? Now in step 2 or step 1 here, what is your xn? Your xn, if you guys remember, or your x current, equals your xn minus 1, which is your x passed, plus your step, which is your h. And so what we'll do is my x passed is 0 plus my step, which is 0.1. This will give me 0.1, and my yn. Now what's your y current? My y current equals to your y passed plus your step times the function. So this is the function. So it's not times the function, times the result of the function. But what is the result of the function? You would put your x passed and you put your y passed. All right. And so you take this equation and you plug in your x passed and your y passed. So if we take this equation and we go, my y passed is 1 plus my step size, which is 0.1, times my function with these values. So my function, my y is my y passed, which is 1. My x, I know I did comma. My x in this way, so it's plus. My x from the past is 0. And my y from the past is 1. And so 0 times 1 is 0, plus 1 is 1. 1 times 0.1 is 0.1. This will give us 1.1. Right? Now on to step 2. We get x from the past plus our h will give us 0.2. And so what you can do is you can fill this out. Step 3, 0.2 plus 0.1 is 0.3. On step 4, 0.4. And on step 5, we get 0.5. And we want the approximation here. And so here what we'll have is x from the past, y from the past, 1.1, plus my step size, my y from the past, plus my x from the past, times my 1.1 from the past. I'm getting this value from here. I'm just submitting in this equation. Okay? And this is going to equal you some number. Down here, we have whatever your y n minus 1, which would be here, that would go here. So whatever equals here. I'm trying to make the video not as long because I'm just trying to show you the steps. You can do the calculator part. And so you'll do this plus your x from the past. And you'll have, this will also go here. And plus your x from the past. This is actually your h. So this is why you should practice this, so you don't make these little mistakes. This is easy marks, but if you make these little mistakes, you'll get miss marks for no reason, and you're going to be pissed. So times my value, my equals, and that will equal a new number. And then you'll do the same thing. So you take this equal number, you bring it at the beginning, plus your step plus whatever number you got, sorry, times whatever number you got, which is plus, I can just write better, let me zoom in. Okay, your x from the past, which is 0.3, times whatever you got equals, okay? And you do this one last step, and so you'll bring whatever equals you have down here, plus your step times your same number plus your x from the past and the same number here. Then you do this, and whatever number here you get, that is your answer. And you can say, therefore, the estimate for y at 0.5 equals whatever number you get. Okay? And that is how you do Euler's method.